In this video, we're going to learn about triangle inequalities. With triangle inequalities, we have three different things that we need to look at. First is ordering our sides or our angles. So when we're ordering sides or angles in a triangle, we're always going to look at the biggest side is across from the biggest angle. And then the smallest side is across from the smallest angle. So when we look at an example, it says in triangle DEF, and right there I would stop and I would draw a triangle and I would label all of my corners D, E, and F. So that this way then I can label what the sides are. So D to E, so from D to E, this is going to be 8. E to F is 6. And D to F is 10. And it wants to know which angles from smallest to largest. So again, like the last slide, the biggest angle is across from the biggest side. So the biggest side is 10, so E is the biggest angle. So if I order them from smallest to largest, my largest angle is going to be E. My smallest, the smallest number I have is 6, and if I go across from that, I have D, so the last letter would be F. So DFE would be from smallest to largest. So option D. Another example, we have part of a marching band formed a triangle made with trumpet players on one side, clarinet players on one side, and flute players on the third side. So again, I'm going to label what I have. So it's telling me that one side is made of trumpet players, one side is made of flute players, and one side is made of clarinet players. Then it's telling me the angle formed by the trumpet and flute player. So if I follow trumpet and I follow flute, this is the angle made by those two. This is measuring 45 degrees. The angle formed by the flute and clarinet, so flute and clarinet, they come together down in this corner, measures 68. Which orders the side of the triangle from least to greatest using the instrument names? Well, we only have two angle measures, so we do need to find this third angle measure over here on the left to figure out which is the smallest and which is the largest angle measure. So what we're going to do is we're going to add our two angles and subtract them from 180. So I can also do it like this, 180 minus 45 minus 68. This will give us 67. So our missing angle over here is 67. So now I can look and see, and it wants me to go from least to greatest. So the smallest angle measure I have is 45. And across from that is C, is my clarinet. So clarinets have to be first. That's the smallest. 67 and 68. Well, 67 is smaller than 68. So across from that is the flute. And my leftover is the trumpet. So we've got clarinet, flute, and trumpet in that order, smallest to largest. Our second part of triangle inequalities is figuring out if a triangle exists. So when you're given a set of numbers, the first thing you're going to do is add the two smallest numbers. Then, if the number you get is bigger than the third number, it is a triangle. If the number you get is smaller than the third number, then it is not a triangle. So looking at an example, can the sides of a triangle have lengths 4, 9, and 10? So I'm verifying if this makes a triangle. So I'm going to take my two smaller numbers, 4 and 9, add them together, and I get 13, and compare it to my third number. So 13 is bigger than 10. So because this number is bigger, then yes, it is a triangle. right? If we look at the second example, we have lengths of 2, 5, and 6. So my two smaller numbers are 2 plus 5 gives me 7, and 7 is larger than 6. So this one again is yes, it is a triangle. Remember, if you have something that the two numbers end up being smaller than the third number, then it is not a triangle. And the third thing is, what could the length of a third side be? So if you're given two sides and they say, what could the length of the third side be to make this a triangle? You're going to first subtract the two sides, and then you're going to add the two sides. So we're finding a range. We're finding that the smallest side it could be is going to be on our left over here, the number that we got from subtracting. And over here is going to be the number that we've got from adding. So this symboling here is going to help us show that this is a range, that this is the smallest to the largest and any number in between, and this will always be like this. So an example, a triangle has two side lengths of 14.8 and 4.2. What is the compound inequality? So compound inequality is that symboling this right here. So you can go ahead and just write that right away. Describes the possible lengths for the third side. So just like my Steph said, I'm going to take them and I'm going to subtract them. So 14.8 minus 4.2 is going to give me 12.6, and that's my subtracting number. So I'm going to write that on the left. And then over here on the right side, I need to add them. So 14.8 plus 4.2 is going to give me 0, carry 1, 9, and 1, so 19. So that means that the third side of this to make a triangle could be anywhere from 12.6 to 19, and any number in between them. A second example of this says a triangle has two sides of length 6 and 12. What is the largest possible whole number length for the third side? So we're going to do our whole problem again. I'm going to set up my inequality, so I'm finding the range between it. So I'm going to subtract them. So 12 minus 6 is going to give me 6. And 12 plus 6 is going to give me 18. So I've got a range of 6 to 18, and it says, what is the largest possible whole number? Well, the trick to remember is that this is not saying is or equal to, so it can't actually touch 18. So the biggest number, or the biggest whole number before 18 would actually be 17. If it asks for what is the smallest possible whole number, well, on our small side we have 6, but this doesn't have or equal to, so we can't actually touch 6. So the smallest number before 6 would actually be 7. So if it asks for the smallest, you're going to go one above your small number. If it asks for the largest, you go one below your largest number. So for this question, our answer will be 17. And that's it. I hope you have a great day, and we'll see you this week.